Hello and welcome to my YouTube channel Civil Line. Myself Milan Patel, Assistant Professor at LJIET Institute of Engineering and Technology. Today's topic is about leveling survey. This is the fourth lecture of this topic. In previous lecture, in lecture number 3, we have discussed classification of direct leveling, in which there are 7 types of leveling like simple leveling, differential leveling, fly leveling, profile leveling, cross-section leveling, check leveling, reciprocal leveling are there. In today's lecture, we will cover the computation of RL and various examples of computation of RL. So let's start with computation of RL. First question which comes in your mind is what is RL, which is discussed already in the previous lecture. RL is the vertical distance of the point from datum surface or a reference plane. Okay. For computation of RL, there are 2 methods are there. First is HI method and second is rise and fall method. Let's start with HI method, which is height of instrument method. So what is HI? It is the reduced level of the line of sight, okay, or line of collimation. The reduced level of line of collimation is called as height of instrument. Suppose there is one ground. These are the number of points like 0 meter, 10 meter, 20 meter, 30 meter, 40 meter and 50 meter. We have to find out the levels of these all points. Okay. Suppose we name these points as A, B, C, D, E and F like this. Okay. Suppose there is a mean sea level or a datum surface. There is a benchmark. This is the RL of benchmark. This is the vertical distance of the benchmark from datum surface. This is the one setup. First reading which is taken on benchmark is called as backside BS. This is HI. HI is equal to RL of benchmark plus BS. To find out the levels of these all points, we have to take the staff readings at all points one by one. Okay, like this. Here, setup number 1 having range up to point C. It cannot be used for point D, E and F. For that, different setup is used. Okay, so by setup number 1, we can take readings at A, B and C like this. Okay, the readings are named as station number A reading is IS, station number B reading is IS, because it is the intermediate reading between BS and FS. The last reading which is taken at point C is called as FS. Okay. Now we will find out the RL of all these points A, B and C. So what is RL of A? It can be easily shown in this figure. It is calculated by HI minus IS, which is the staff reading at station number A. Okay. To find out RL of B, similarly HI minus IS, which is the staff reading at B. To find out RL of point C, we can be calculated by HI minus here FS reading. Okay, this is how we can calculate the RL using HI method. Okay, after finding out the RL of point A, B and C, we have to shift the level from setup number 1 to setup number 2 like this and take the readings at D, E and F. For that, first we have to take the readings at the last point, which is the changing point, okay, which is called as BS, because this is the first staff reading of setup number 2. Okay, this is the HI. How can we calculate HI? It is calculated by RL of changing point or RL of C plus BS. Okay, this BS, RL of C plus BS. After that, we can take the readings at D, E and F like this. We can name these readings as IS, IS and FS. Okay, because D and E are the intermediate stations and the readings taken at intermediate stations are called as intermediate staff reading IS. The reading taken at the last point is called as FS. Okay. After that, we can calculate RL of D, E and F like this. RL of D is calculated by HI of this second setup minus IS of this station number D. Okay. To find out the RL of E we can calculate it by HI of this setup minus IS at E. And to find out RL of F, we can calculate it by HI minus Fs. Okay, this is how we can calculate the RL of all points. Okay, this is HI method where HI is calculated first, and using HI we can calculate the RL of all points. Okay. Now let's discuss the second method to calculate RL, which is rise and fall method. In this method, the HI, height of instrument, is not at all calculated, but the difference of level between two consecutive points is found out by comparing the staff readings on 2 points for the same setup. Okay. Here we can calculate the level difference between two consecutive points, okay, by calculating the difference of staff readings which are taken by the same setup. Okay. Suppose there is one ground. These are the points, 2 points, which is A and B. We have to calculate the level difference between these 2 points using rise and fall method, or we have to calculate the RL of A and B using rise and fall method. For that, one setup is prepared in between these 2 points like this, and readings were taken first at station number A, which is like this. This is 1 meter suppose. After that, we can take the readings at station number B. Suppose this is 0.5 meter. So what is rise or what is fall? We can calculate by calculating the difference of two consecutive staff readings. Okay. So we have to calculate the difference of these two staff readings, 1 and 0.5. Okay. If the forward staff reading is smaller than the immediately preceding staff reading, then it indicates rise. Okay, here you can clearly see the preceding staff reading is 1 meter and forward staff reading is 0.5 meter, which is smaller than the preceding staff reading. So it indicates rise. You can clearly see in this figure also, A is at down slope while B is at a rising slope. Okay, you can clearly see the rise of the ground. Okay. To calculate rise, we have to deduct these staff readings. Okay, 1 minus 0.5. If the difference is positive, here 0.5 is positive, so it is called as rise. If the difference is negative, it can be fall. Okay. After finding out rise or fall, we can calculate the RL of these points. Okay. For that, this statement is used. If there is a rise, the rise is added to the RL of preceding point to get the RL of the forward point. Okay. Suppose the RL of station number A is 100 meters. To find out the RL of B, we have to calculate the rise or fall. Okay. Here there is a rise of 0.5 meter. Okay. So RL of B is calculated by RL of A plus rise, because rise is always added to the RL of preceding point to get the RL of forward point. Okay. To find out RL of B, we have to add rise into the RL of A like this. Okay. So here RL of A 100 meter, rise 0.5 meter. So RL of B can be calculated as 100.5 meter. Okay. This is how we can calculate RL of point using rise and fall method. Now we will understand this method where there is a fall in the ground. Okay. Suppose this is the one ground. These are the 2 points A and B. Okay. To find out the RL of B and A, we have to set up the dumpy level like this. First, we will take the reading at station number A. Suppose there is a 0.5. After that, we will take the reading at station number B. Suppose this reading is 2 meter. To find out rise or fall, we have to deduct the forward staff reading from preceding staff reading. So, to find out rise or fall, we have to find out 0.5 minus 2. Okay. If the forward staff reading is larger than immediately preceding staff reading, that it indicates fall. So fall is equal to 0.5 minus 2 meter. Here the value of differences between forward staff reading to the preceding staff reading is in minus sign. So there is a fall. Okay, here 1.5 meter fall is there between these 2 points. Okay, after finding out rise or fall, we can calculate RL. Here there is a fall. If there is a fall in the ground, the fall is subtracted from the RL of proceeding point to get the RL of forward point. Suppose RL of A is 100 meter. To find out RL of B, we have to deduct this fall from RL of A. Okay, so RL of B can be calculated by 100 minus 1.5, 98.5 meter. Okay, this is how we can calculate RL of points using rise and fall method. Now let's move to the examples of computation of RL. First example, the following consecutive readings were taken with a dumpy level along a chain line at a common interval of 5 meters. The position of instrument was changed after 3rd, 7th and 10th readings. Draw the form of level book and enter the readings properly. Assume the RL of first point as 50 meters. Calculate RL of all points and apply usual checks. Use first HI method and then rise and fall method. So using this example or understanding this example, we can easily understand how to calculate RL of points using HI method as well as rise and fall method. Okay, these are the readings given in the examples. Okay, first of all we have to give names to each readings. Okay, first reading is taken as BS, last reading is always FS. After 3rd, 7th and 10th reading, instrument was shifted. So 3rd, 7th and 10th reading is the last reading of the setups. So 3rd reading is FS, 7th reading is FS and 10th reading is FS. After taking FS, the instrument was shifted and then first reading was taken of the second instrument or second setup. Okay, so after FS there is one BS is there. Okay, so there are the BS. In between FS and BS, the readings which are there are IS. Okay, these are the IS. Okay, this is how we can name the readings. After naming the readings, we are preparing the page of level book. Okay, like this. This is the page of level book. Okay, in this there are 8 columns are there: station, chainage, BS, IS, FS, HI, RL and remarks. Okay, first of all, first station, which is at 0 meter. Chainage is the distance between 2 points. Okay, at first station the reading is BS, so it is written as this 0.35. Okay, the RL of first point is given in the example 50 meters. So 50 meter is already given. Okay, which is the benchmark. So in remark column, in station number 1 we can write benchmark. Okay, after this we can calculate HI. Okay, what is HI? HI is equal to RL of benchmark plus BS. So here 50 plus 0.35, HI is equal to 50.35 meter. Okay, then station number 2, which is at 5 meter interval, because one interval is given in the example which is 5 meter. So each station is having interval of 5 meter. So second station is at 5 meter, which is IS, which is 0.58. Okay, then third station is at 10 meter, which is FS, which is 0.645. Next reading is BS. Okay, after third reading, instrument was shifted. Okay, after shifting the instrument, the first reading is taken at the last point. Okay, where FS is taken. Okay, so FS and BS are there for third station. Okay, so BS 1.85 is written in the third station. Okay, after this IS is there 1.935, then 2.45 at 20 meter, then FS is there at 25 meter 1.75. FS and BS are there because changing point is there. Okay, so there are 2 staff readings are there at changing point. Okay, then 0.72 is IS, then FS is there. Okay, after FS BS is there, so there is a changing point, can be written in remarks column. Okay, then last reading is FS, so it is written in FS column. After filling these three columns BS, IS and FS, we can calculate the RL of all points like this. First, RL of first station is given in the example 50 meter. Then after we can calculate HI 50 plus 0.35, RL of benchmark plus BS which is 50.35. Then after, to calculate RL of second station, we can find out it by deducting the staff reading from HI. So 50.35 minus 0.58 gives the RL of second point. Okay. To find out RL of third point, the similar way, HI minus the staff reading. Here in third station, the staff reading is 0.645, which is FS. Okay. Here HI is of first setup. So the readings which are deducted from HI is also from first setup. Here in third station, two readings are there, 1.85 and 0.645. But 1.85 is of second setup, while 0.645 is of first setup. Okay, and the HI is also of first setup. So we have to deduct the staff reading which is taken from that setup only. So 50.35 minus 0.645, which is 49.705, the RL of third station. After that, there is a changing point is there, instrument was shifted. After shifting the instrument, we have to calculate the new HI. Okay, so new HI can be calculated as RL of changing point, which is 49.705 plus BS 1.85 gives 51.555. This is the new HI. Okay, to find out RL of station number 4 and 5, we have to deduct that readings from HI. 51.555 minus 1.935 gives 49.62. 51.555 minus 2.45 gives 49.105. Okay. Then to find out RL of 6th station, okay, we have to deduct the reading 1.75 from 51.555 because 1.75 staff reading was taken from second setup, and this 51.555 is also the HI of second setup. Okay, so 51.555 minus 1.75 gives 49.805. Okay, this is the changing point. So we have to calculate new HI. To calculate new HI, we have to add BS in the RL of changing point. So here RL of changing point is 49.805 plus BS 0.36 gives 50.165 new HI. Okay. After that, to calculate RL of station number 7, we have to deduct this reading 0.72 from HI. 50.165 minus 0.72 gives 49.445. To calculate RL of station number 8, we have to deduct the reading FS from HI. 50.165 minus 1.2 gives 48.965. Here also there is a changing point is there. So new HI can be calculated. RL of changing point 48.965 plus BS 0.92 gives new HI 49.885. Okay. To calculate the RL of last point, station number 9, we have to deduct the readings of station number 9 0.63 from HI of that setup. Okay, 49.885 minus 0.63 gives 49.255. Okay, this is how we can calculate RL of all points using HI method. Okay, after finding this RL, we have to check this RL. For checking the RL, we have to calculate two sums, sigma BS as well as sigma FS. Sigma BS is the sum of the readings of BS. Okay, sigma FS is the sum of FS readings. Sigma BS is 3.48, sigma FS is 4.225. Now we will check the reading is correct or not. In HI method, the check is like this. Sigma BS minus sigma FS should be equal to last RL minus first RL. Okay, so 3.48 minus 4.225 should be equal to 49.255 minus 50 meter. Here the values are similar, so check is okay, and the readings which we have just calculated are the correct one. Okay, this is how we can calculate and check the readings of RL using HI method. Now we will calculate the RL of points using rise and fall method. Okay, these are the readings. Okay, using this reading we can prepare the page of level book like this. Here there is one change is there. in rise and fall method, HI cannot be calculated. Okay, so HI column is missing. Okay, instead of HI, two columns are added, which are rise and fall. Okay, there is a change from the previous method. Okay, so first of all, we have to insert these readings into this table. Okay, station number 1, the first reading is BS, so it is written in the BS column. Okay, then after second reading is IS, so at the 5-meter interval second station is there. Because of it is IS, it is written in the IS column. Third reading is FS, so it is written in the FS column. Okay, this is the third station at 10 meter. After FS, the instrument was shifted, so it is written as changing point 1. Okay, at changing point, two readings are there. So next BS reading is also at 10 meter or at station number 3. So 1.85 is written in this column, not in this column. Okay, this is 1.85. Next reading is IS 1.935 at 15-meter interval. Next is 2.45 IS, so it written in IS column. Next is 1.75, which is FS. Okay, when FS is come, which is the last reading, then after the instrument was shifted, so in remarks column we have to write changing point 2. Okay, at changing point, two staff readings are taken, FS and BS. So we have written already FS, so next reading BS is also written in this station number 6, which is 0.36. Next is IS 0.72, so it is written in IS column. Next is FS, so it is written in FS. When FS comes, there is a changing point. At changing point, two staff readings are taken, so next BS reading is also at station number 8. Okay, and the last reading is FS, so it is written in FS column. So we can easily write the values in the first 5 columns: station, chainage, BS, IS and FS. Then after, we have to calculate rise or fall for each station. Okay, so in first station there is no preceding station, so we cannot calculate rise and fall. Okay, so there is a dashed line is there. Then after, in second station we can calculate rise or fall by comparing the readings with the preceding staff reading, which is at station number 1. Okay, so to calculate rise or fall of station number 2, we have to deduct the readings of station number 2 from the preceding staff reading, which is 0.35. So 0.35 minus 0.58. Okay, the value is 0.23 in minus sign. So when the difference is in minus sign, it is written in the fall column like this. So 0.35 minus 0.58 minus 0.23, so it is written in 0.23 fall. Okay, then after, to find out rise or fall of third station, we have to deduct the reading of third station from preceding staff reading 0.58. So 0.58 minus 0.645, the value is in minus, so it written in fall column. Okay, then to find out rise or fall of fourth station, okay, we have to deduct the value of this staff reading from preceding staff reading. Okay, here the preceding staff readings are 2, 1.85 and 0.645 also, but this 1.935 is taken from the second setup. Okay, 0.645 is taken from the first setup, so the setups are different, so we cannot calculate rise or fall using two different setups. The setup should be same. Okay, so we have to deduct 1.935 from 1.85, because 1.85 is also taken from second setup, 1.935 is also taken from the second setup. Okay, so 1.85 minus 1.935 gives minus 0.085. Because of the minus sign, it is written in fall column. Okay, to find out rise or fall of fifth station, we have to deduct 1.935 minus 2.45. The value is in minus, so it is written in fall column. Next, to find out rise or fall of sixth station, we have to deduct 1.75 from 2.45. So here 2.45 minus 1.75 gives plus 0.7. Because of the plus sign, it is written in rise column. After that, to calculate rise or fall of seventh station, we have to deduct the value of 0.72 from preceding staff reading of same setup. So 0.36 minus 0.72 minus 0.36, because of the minus sign it is written in fall column. Okay, then after, to find out rise or fall of each station, okay, we have to deduct the value of 1.2 from the preceding staff reading, which is 0.72. So 0.72 minus 1.2 gives minus 0.48. Because of the minus sign it is written in fall column. And the last rise or fall of 9th station we can calculate by deducting 0.63 from 0.92. Why? Because this BS and FS reading are taken by the same setup. This 1.2 is taken by another setup, so we cannot use this reading. We have to use this reading for calculating rise or fall. So 0.92 minus 0.63 gives plus 0.29. Because of the plus sign it is written in rise column. So we can easily calculate rise or fall of each stations like this. Okay, after finding out rise or fall of each stations, we can calculate RL of all points. Okay, we have RL of first point in the example, which is 50 meter. We can easily return as benchmark. Okay, because of non-RL value. Okay, after that, to find out RL of second station, we have to use rise or fall. If there is a rise, we have to add the value from preceding RL. Okay, if there is a fall, we have to deduct the fall value from preceding RL. Here there is a fall, so we have to deduct this value from preceding RL. Okay, so preceding RL is 50 meter. 50 meter minus 0.23 gives 49.77. Next, here also there is a fall, so we have to deduct this value from preceding value, which is 49.77. So 49.77 minus 0.065 gives 49.705. Okay, 49.705 minus 0.085 gives 49.62. 49.62 minus 0.515 gives 49.105. 49.105 plus 0.7. Why there is a plus? Because it is the rise. When there is a rise in the station, we have to add the value of rise into the preceding RL. So 49.105 plus 0.7 gives 49.805. 49.805 minus 0.36 gives 49.445. 49.445 minus 0.48 gives 48.965. 48.965 plus 0.29, because of the rise there is a plus sign. 48.965 plus 0.29 gives 49.255. This is how we can calculate the RL of all points easily. Okay, after calculating the RL, we have to check this RL of all points like this. So here in rise and fall column, check is like this. Sigma BS minus sigma FS should be equal to sigma rise minus sigma fall should be equal to last RL minus first RL. So sigma BS, we have the value 3.48. Sigma FS, we have the value 4.225. Sigma rise, which is the sum of rise values, which is 0.99. And sigma fall, which is the sum of fall values, okay, which is 1.735. Okay, we can easily check the values of RL like this. Okay, here all the values are similar, minus 0.745. So the check is okay. The RL of all points which we have just calculated are corrected one. Okay, this is how we can check and calculate RL of all points using rise and fall method. Okay, now let's move to the next example. The following consecutive readings were taken with a dumpy level and 4 meter leveling staff on a continuously sloping ground at 30 meter common interval. Okay, so 30 meter, here is the chain H1. Draw the form of level book and enter the readings properly. Assume the RL of first point as 80.75. So this is a RL of benchmark, you can say. Calculate RL of all points using rise and fall method only and apply the necessary checks. Also find gradient of line joining first and last point. If in example the method is given, we have to use that method only. If there is no mention of the method of the example, you can use any one method. Okay, these are the readings which we are given. Here one change in example is that there is no mention of shifting of instrument. Okay, we have to judge by our own by using these readings. Here you can clearly see the readings are gradually increasing and suddenly decreasing. Okay, the readings are gradually increasing and suddenly decreasing, increasing and suddenly decreasing like this. Okay, so readings are gradually increasing initially, but then they suddenly decrease after 6th and 10th reading. Okay, this indicates the instrument shifted after 6th and 10th readings. Okay, so now we can name these readings. Okay, first reading is always BS, last reading is always FS. Okay, after 6th reading instrument was shifted. Okay, so sixth reading is FS. After 10th reading instrument was shifted, so this is also FS. After FS always there is BS. Okay, and in between BS and FS there are always IS is there. So this is how we can name the readings. Okay, after naming the readings we have to prepare the table. Okay, because in the example rise and fall method is given, so we have to prepare the table of rise and fall. Okay, like this. So first station is at 0 meter. Okay, the reading is 0.68, which is BS, so it is written in BS column. Second station is at 30 meter, because in example the interval 30 meter is already given, so here 30 meter is there. Second reading is IS, so it is written in IS. Third reading is IS, so it is written in IS column. Fourth is IS, fifth is IS, sixth is FS. When FS is come, always changing point is there. Okay, at changing point two step reading is taken, FS and BS. So this BS reading is also at the station number 6, 1.055. Okay, next is IS, so it is written in IS. Next is also IS, 2.265. 3.54 is the FS one, so there is a changing point. At changing point, two step reading is there. So next reading BS is in the station number 9.835. Okay, then next is 0.945 and 1.53 is also IS, so it is written in IS column. And the last is 2.25, which is FS, so it is written in FS. Okay, after writing these all values in BS, IS and FS column, we are calculating rise and fall of each stations. Okay, here in example RL of first point is already given, which is 8.75. Okay, so in remarks column we can write as benchmark. First we will calculate rise or fall of each station. To calculate rise or fall, we have to deduct the value of the station's staff reading from preceding staff reading. Okay, so to calculate rise or fall of station number 2, we have to deduct the staff reading of station number 2, which is 1.45, from immediately proceeding staff reading, which is 0.68. So 0.68 minus 1.45, 455 gives negative value, so it is written in fall column. This is how we can calculate rise or fall of each stations. After finding out rise or fall, we can calculate RL of all points by adding or deducting the value of rise or fall from preceding RL. So we have the RL of first point 80.75. To calculate RL of second station, we have to use rise or fall. Here there is a fall, so if there is a fall in the station, we have to deduct this fall value from preceding RL. So 80.75 minus 0.775 gives 79.975. In third station there is also a fall, so it should be deducted from preceding RL. 79.975 minus 0.4 gives 79.575. This is how we can calculate RL of all points. Okay, after calculating RL of all points, we have to check this RL. For checking the RL in rise and fall method, we have to use sigma BS minus sigma FS should be equal to sigma rise minus sigma fall should be equal to last RL minus first RL. So here the values are similar, minus 6.6. So check is okay. The above RL values of all points are corrected one. Okay, this is how we can calculate the RL of all points where there is a continuously sloping curve. Okay, here in example all the values are in fall column because there is a continuously falling ground inside. Okay, in this example we have to calculate the gradient because it is asked in the example. Okay, so the gradient can be found out by taking the ratio of difference of RL of last point and first point to the difference of horizontal distance. So difference of RL of last point and first point is 6.6 and the difference of horizontal distance or chain it is 330 meter. So 6.6 divided by 330, okay, is 1 upon 50. Okay, we have to divide it by 6.6. So above value is also divided by 6.6. 330 is also divided by 6.6. So this is 1. 330 divided by 6.6 gives 50 value. Okay, here the value of RL is decreasing from first point to last point, so it is called as a falling type of gradient. Okay, this is how we can calculate the gradient between first and last point. Okay, that's all about the various types of examples of computation of RL. I hope you all understand the two methods of computation of RL, which is HI method and rise and fall method. See you soon in the next lecture. Thank you for watching. Don't forget to like, share and subscribe to my YouTube channel, Civil Line. Thank you.